Hello everyone and welcome to the next episode of the Dynamic Unit tutorial. In this tutorial we will continue working with the shaft furnace that we made in the previous tutorials. We will add some more dynamic functionalities into the shaft furnace, such as separating the unit into upper and lower section, and also using the delay stream to add more time delay to the unit. We will also change the operation to use the equilibrium operation instead of the elemental distribution operation. Let's start by visualizing our plans a little bit. So we will divide the shaft furnace into upper and lower section, and we want the magnetite and coal be fed from top of the shaft furnace and slowly proceed through the furnace to the bottom and then exit from there. And then we want the air to be fed from the opposite direction, first to the lower section, and then move through the lower section to the upper section, while reacting with the magnetite and coal that are fed to the other direction. So let's open up the unit editor, and first let's add the lower section into our system. So we add another tank over here. We change the first tank's name to upper section, and the second one is lower section. And then we have to make sure that from the input, the air goes first to the lower section and the solids go to the upper section. So we go to the dist sheet, and here we can see how the inputs are distributed into the tanks. So now everything goes to the upper section. So I want to change the air to go first to the lower one. Okay, that seems all right. And for now, let's switch off the controls, since we are making quite big modifications for our system. So we don't want to adjust our system yet, because we will try to make the principal model ready first. So I'll just switch those off. I will also go into the dynamic dialog and switch off the set sheet that we had set in the previous tutorial. So I will go here and switch it off. So now the set sheet won't change these values during calculation. Next, let's do the necessary changes to the operation. So before we used the elemental distribution operation, but now we want to use the chemical equilibrium instead. So I select that one. Then I need to make sure that all the settings are correctly here. So gas is mixed phase, yeah. Solid is not mixed, it should be pure. Okay, and then I can change the rate, measurement units. All right. And now everything that comes into this operation is sent back to the upper section. We might have to change this later on, but let's start with these values. So let's test out our model first without having any operation rates or any output rates. So I will just make everything 0 and I will empty the tanks. And now if I calculate, okay, it seems to be working fine. So in the lower section, we get the air feed as we wanted to define. And in the upper section, we get all the solid feed. So that is now working correctly. Now let's test out next what happens if we feed our phases to the operation. So we feed, let's say, 10% of the solid phase there, 90% of the gas phase from the lower section. And I will now put the automated empty tanks before calculation starts. So now whenever I start new calculation, it will always empty the tanks, so I can start from scratch. So now if I calculate, we can see that the mass and energy amount will increase in the upper section, but stay stable in the lower section. And this is now going according to how we have defined the operation. So in the operation sheet, we have defined that everything that comes to the operation, 100% goes to the upper section. So we send mass from the lower section to the operation, but because of this definition, what we have over here, then everything ends up in the upper section. So we can see that we start to have CO2 here in the upper section, and also the temperature starts to increase. So the equilibrium operation itself seems to be working fine. The numbers are a little bit different than before because the elemental distribution was set with the percentages, and this one is calculated automatically by the equilibrium. Next, let's try to move this mass from the solid phase to from the upper section to the lower section. So we can go to the operation and we can change the solid output from the operation to go to the lower section. And now if I calculate and see the results, then we can see that we start to accumulate some hematite to the lower section, and in the upper section we have mainly magnetite and some coal as well. So this seems to be working reasonably at the moment. Next, let's define some outputs for our upper and lower sections. So we want the gas to exit from the upper section to the process gas output stream, and the solid phase we want to exit from lower section solid phase to the hematite pellets. So now if we calculate, in the end the process stabilizes to some numbers, both with the masses and the temperatures of the tanks. And if I now go to the output sheet, I can see that we have similar output as what we had in the previous tutorial. At this moment, we still don't have any kind of reasonable delay for the solid phase. So now, whenever we start the calculation, after starting it, quite soon we will see the change in the output hematite pellets. So let's add the delay now. And one way to do this is to add a stream and then change it to delay stream. So I draw a new stream and then I change it to delay. And now if I go back to the unit, we can see that we have that delay stream now over here. And to change the delay time for the stream, I have to go to the dynamic dialog. And here we have the streams sheet over here, which lists all the streams that we have in the flow sheet. And here I can write the delay in seconds. So if I want the delay to be, let's say, 2 hours, so I just calculate 60 times 60 times 2, so 7,200 seconds. And now I want to send part of the phase to the delay stream. So I change 10% over here, And instead of using the operation to transfer the material between the tanks, I won't be using this, so I will change it back so that everything goes back to the upper section. And now the delay stream will be the one moving the mass between the tanks. I have to make sure that in the dist sheet I have the correct destination. So now the delay stream will put everything to the upper section. I don't want that. Instead, I want everything to go to the lower section. Now if we calculate, let's see what happens. Okay, now it finished calculating the 8 minutes. We see that nothing comes to the lower section. That's because we set the delay to be 2 hours for the delay stream. So that's why, because after 8 minutes, that time is not enough to transfer the material from the delay to the lower section. That's why we don't see any mass accumulation in the lower section now. So how to change this? We can go to the dynamic dialog. We keep the 2-hour delay, but we will change the calculation step to 1 minute. And we can change the end time, or we can just say run until paused. And then close this. And now try again. Okay, so now we saw something happening here. And now if we go to the dynamic dialog and we look at our charts, what we have here, then we can see that the feed rate stays constant, but the hematite pellets will start coming out after the 2-hour mark has passed. Okay, so now we only have one operation happening, so only the solid material from the upper section react with the equilibrium. Once it reaches the lower section, it doesn't react in any way at the moment. So probably we might want to change it so that also the lower section reacts before it goes out of the system. So we can do that by making another operation. So I press this duplicate operation for my operation 1, and it will create a copy of the first one. And I will rename these. So this one will be the lower section operation. So I will mark it with OP. And then this one will be upper section operation. Okay. And now from the upper section operation, everything gets to the upper section, and from the lower, everything gets to the lower section. If we now go back to the tanks, we can see both of the operations here. And now they both have this 1 as a calculation index over here, meaning that they are calculated at the same time. Now, we don't necessarily want that. We might want to make it so that the lower section operation is calculated first, and then whatever gas phase we have after the lower section operation, it participates into the upper section operation and then goes to the upper section and then leaves the system. So we can change the calculation index over here to set the order of calculation for the operations. So I put it as 2 and keep this as 1. And now we can see that we have number 2 over here for the calculation index. Sometimes it doesn't refresh it, so if you want to refresh it, you can just type to the cell and press enter. And now we can see that, okay, we have our operations here in the correct order. Next, we have to fix the percentages for the operations. So currently there is no error going to the lower section operation. So I will put there 100% for that. Then solid phase to the lower section. Okay, from the upper section, none of the solid phase goes there. So that remains 0. Then for the upper section, let's put 20% there. And then for the solids in the lower section, probably because it's closer to the air inlet, so I will put a higher percentage there, so that not everything happens in the upper section, so that we also have some reactions there. Okay, so the percentages are set. We can try out how it goes with these. So we start calculations. And then we end up with this kind of temperature profile in the upper and lower section. And if we take a look in the output sheet, then we can see what kind of hematite pellets we have, and it seems all right. Okay. We can also check the charts, how they look. So we can go here and we see how the feed rate is all the time 200, but after 2 hours we start to produce some hematite pellets. Also the output composition stays quite stable when it starts to come out, so it's looking okay. Then next we can try to adjust the controls. So we have 2 PID controls here. And now we set up the P parameter for the 1 second time step. We have changed it to 1 minute afterwards. So I will decrease the proportional gain a little bit and then see how it goes. So if we run the model, okay, seems to be behaving maybe okay. We can see in the tank sheet that the temperatures start to now approach the 700 that we have the set point for. Also in the output we have the O2 5%. Looking good there. Then we can set up the schedule sheet. So now we are running only with constant 200. So we can change it to run with different feed rates. So after 10 hours we change, after 20 hours we change. Let's see how this goes. Now the temperature doesn't have time to settle to the PID control set point, since we are changing it all the time. Okay, I think that's enough. Let's see the charts. Okay, we have a constant composition, feed rate changes at 10 hours and 20 hours, and then the hematite pellet production changes afterwards with the delay. Seems to be working fine there. We might also be interested to see the temperature profile in the function of time. So let's take the two cell references over here. Go to the dynamic dialog and add them to the get sheet. Add cell references. And then we have here the upper section, lower section, and then close the window and calculate. You can also see that by closing the dynamic dialog and closing the unit editor, we can increase the speed of the dynamic calculation, because the unit doesn't need to update the excels during every calculation round now visually. So that's why it can be a bit faster if you close those two dialogs. Okay, so everything looking fine here. We can make this full screen. Okay, maybe we don't need this chart, or we change the data that it contains. So instead of having the compositions there, let's have the temperatures. Okay, so here we now have the temperature profile there, and because of the delay stream, we have this kind of small fluctuation there. So the delay stream always brings the mass after 2-hour delay, and then it affects also the air, how it goes through from the lower to the upper section. So that's why we see some differences there, but all these numbers also settle after running it for a while. Okay, looking good. So the model we have made here works fine. However, of course, this is a very simple model, so it's not supposed to resemble how the exactly how the real shaft furnace works. Instead, here we have been able to demonstrate the functionalities of the dynamic unit and also the logic how it works. Finally, let's make a short summary what happens inside the dynamic unit during the calculations. So the calculation order is of course the same as what we covered previously in the tutorial. So first we calculate the inputs, then the operations, then the outputs. So in this case, our shaft furnace looks like this. So we have two tanks, lower section, upper section tank. Then we have two operations, one for the upper section, one for the lower section. And then both of the tank contain solid and gas phase. And then we have the delay stream here. So calculation round 1, the first step, inputs. So all the solid inputs go to the upper section. All the gas inputs go to the gas phase in the lower section. Then we calculate the first operation in the calculation index, which we define to be the lower section operation. Nothing really happens there because we don't have any solid phase coming there from the lower section. That is empty at the moment. Then we calculate the second operation, and the gas phase from the lower section participates there, as well as the solid phase from the upper section. Then the gas goes to the upper section gas phase, and the solid phase goes also to the upper section. Then we calculate the outputs, and 10% of the solid phase go to the delay stream, 90% of the gas phase go to the output. Then after 2 hours, the first step looks like this. So otherwise it is the same, except that the delay stream now inserts some mass from the delay stream into the solid phase. Then in the first operation, besides the gas phase that participated into it before, we also have the solid phase participating into the lower section operation. So something actually happens now in here, and the solid phase returns to the solid phase in the lower section, and the gas phase to the gas phase. Then the following operations go as before. So the second operation, the upper section, the gas phase from the lower section participates into that, as well as the upper section solid phase, and the phases return to the upper section. And then we calculate the outputs again. 10% of the solid phase here, 10% of this solid phase goes to the delay stream, and 90% goes to the gas, from the gas phase goes to the output. So now in this tutorial we have learned how to use multiple tanks and multiple operations in the dynamic unit, how they work and how the calculation logic goes. Also we learned how to use the delay streams, and we also added some more variables to the graphs in the dynamic dialog. This concludes the tutorial. Thank you for watching.